Okay, so good morning, everyone. Welcome to whatever day this is, day of GSE, fourth day, if you don't include the Mondays, this sixth day, if you include the Mondays. I hope you're all having an excellent GSE conference. If you have any questions during this session, can you please put them in the chat window? And I'll either relay them to Roberto during the session, or we'll ask them at the end, depending on what appears to be appropriate. There were some things last week where people thought it was quite nice to keep the session open rather than close it as soon as the presentation is finished, for the group that were in the presentation to chat. So I will be leaving the session open for about 10 minutes after its conclusion, so that you can chat amongst yourselves. I will give you the ability to unmute yourselves at that point in time. So without any more issues things to talk about, I will pass you over to Roberto for his session, Fine-Tune Your Mainframe Performance Through the Analysis of WLM and HIS. Thank you, Roberto.
Okay, thank you, Anna. Hello, everyone. I'm Roberto Pacheco from ZOS. I have been working at ZOS since 2018, leading the pre-sales activities on ZOS solutions. And I hope everybody is safe with this situation of COVID. And thank you very much for joining us on this session. So the idea here is to talk about WLM and HIS a little bit, and how to analyze some KPIs coming from the ZOS logs. Okay, let's get started. So here is the agenda. So we are going to talk about ZOS logs, SMF records, and then we go through HIS and WLM. Okay, feel free to make questions. I'll try to answer all of them at the end of this session. And let's go. So first of all, just explain who is ZOS. ZOS is a French company that was created in 2006, based in Nantes, France, and has a global presence through the Alliance network, so business partners around the world. We have more than 60 customers, and actually we have 4 different solutions, all of them under the ZOS umbrella. So ZOS was the former ZOS management company. So this year they decide to change the name to ZOS. And just for information, I don't know if everybody knows, ZOS Management is the company that launched the software Outsoft Capping. That was a software for dynamic distribution on MSUs on CPC resources through the LPARs according the workload. So in this solution, this ZOS family has many solutions, but today we are not talking about products. It's just to understand who is ZOS and what we do. Okay, so let's start with the ZOS log analysis. Log analysis, ZOS provides a lot of interesting information, and everything you do inside the ZOS, it's registered in logs. So mainly we have on those logs we can see we have several insights, performance bottlenecks, capacity planning, We can do capacity planning based on the history of the logs. We can see system problems, or we can see opportunities to improve our environment. And also, and I think that's most important one, we have a better understanding about what's going on the environment. So talking about SMF records, everybody knows that the SMF records are generated on ZOS for everything you do. Since a logon on TSO, a job you start, you execute, or STC that you close, everything, or one data set access, everything you do on ZOS is registered on SMF logs. Today we have 255 different SMF logs. The first 128 are related to IBM. So for the ZOS components and some IBM softwares, and the other 127 are related to ISV products and other IBM products. So the SMF records are ready to be used, but they need to be analyzed. They are it's not understandable by itself. You have to have knowledge and expertise to translate the binary information you have inside the SMF record to something that you can understand and you can work with. So the SMF records are generated all the time, and depending on the shop, it can be a huge amount of data. They are huge amount of data, and because of this, sometimes it's difficult to store and collect. So you have many processes on the environment to select specific SMF records to manage them. But the most problem here is that sometimes it's complex to understand. So as I said, you have to have knowledge. You have to know to map them, see the layout. And also it's difficult to correlate because one event can sometimes generate many SMF records. And it's difficult when you need to correlate them to have the big picture of what happened on your environment. So I put here on the bottom that's time consuming because you need to have all this understanding to use those SMF records. And just out of curiosity, this is an example of SMF records. So as you can see, you have many binary information and only few fields you can understand. It should be here the LPAR name, here the ZOS version, or here is the sysplex name. So depending on, you have few fields that are character. Almost all of them are binary and you have to convert to decimal, or it's a date, or you need to do some calculation. So always you have to do something with the SMF fields. And this is a nice information that the SMF records were created in 1969 with the system 360. Okay, but apart from the logs, we have the hardware instrumentation services. That's one component from ZOS, from the CPC actually, that we can use to. So this function it's a function that collects different information from the hardware. So it was available since the IBM system Z10, and now it's more than it's really used to understand how the hardware is performing. It's not activated by default. You need to set up this feature in order to be used. And you have, with using this information, you have different counters to understand the hardware behavior and the hardware configuration. So also you can see information on crypto processors and LPAR configuration, cache levels, the speed of the instruction execution, and other stuff. So to activate that, you have to access your support element or through HMC and basically activate the counter facility security options. And here you choose which one you want to activate to have the information collected by HIS. So here I put two screenshots. One when you want to change it dynamically with change LPAR controls. Another here just when you want to set up this using the activation profiles. Okay. On the ZOS side, you have to do some things as well, not only on support element and or through HMC. On the ZOS side, you have to set up the HIS proc. Also, you have some one command that you have to customize according your needs, what you want to have from this from HIS. I will not spend time on the parameters you have on the modify begin. It's just to say that the SMF 113, that's the SMF generated by HIS, is generated by default, but also you can, if you want to define this CNT files that will be written on Unix system services, so you can do that as well. And using this command, you'll be able to set up the CNT files and also other parameters. And also, usually it's good to have the SMF13 on the SMF interval basis. So if you need to adjust this parameter, you can use the SMF interval on the modify HIS proc begin. Also, if you want to finish the collect from SMF 113, it's the modify HIS proc virgule end, comma when end. Okay. And now talking about the SMF 113 counters, you have interesting information about the catch levels and other parameters. We'll talk about CPI, RNI, and the catch levels. And then we can have a better understanding how your LPAR is performing. So you can see identify issues and also see if it's performing well. The hard when you have changes on your environment, so you can keep tracking those counters to see if your hardware is performing well. So there are different counters on the SMF 113. You have the base counters that the most used ones, together with problem state and extended counters. All of them are used to measure the catch levels and CPI and RNI. But also you have the crypto counters used to analyze the crypto processors. And you have the MT diagnostic counters that is used by IBM when they need to see what's going on the machine. Basically, what we use, it's the basic counters, problem state counters, and extended counters. And if you want to see the crypto information, you use the crypto counters. So on the right-hand side here, we have the picture of the catch levels, where we have the processors, L1, that's the near of the processor, and L2 as well. And then we have the memory hierarchy here, L3, L4, and memory, and L4 remote. So we have up to 5 drawers on Z15. And HIS will bring us some information on the access of those cache levels that we understand how our environment is performing. So you have the cache level 1, 2, 3, and 4, memory, and then for remote. You have all those KPIs inside the SMF 113, and they dictate the speed. So the more your data is far from the processor, so more time you need to execute your transactions. So put this in a simple way. And the CPI is the metric we use to understand the amount of cycles needed to execute an instruction based on the cache levels access where the data is stored. And also we have the RNI, that's a KPI used to understand the activity you have on the memory hierarchy. So the higher RNI you have, the deeper you are going in the memory. So far you are going to access the information on the cache levels. So to understand the behavior of your workload or of your environment, you can use the level 1 MIS. That's another KPI available on SMF 113, and the RNI. So you can understand the category of your workload on the environment. Here on the left-hand side, we have a table that it's just a reference to categorize your workload. So the majority of customers of the companies have an average RNI, but depending on your process running on the system, it can be a lower RNI or a higher RNI. So the RNI is the metric to tell you if you are how far you are going to the cache levels, where a higher RNI means that you are using heavily the memory hierarchy, and the lower RNI means that you are using the L1 and L2 processors at most. So here are some screenshots that you can create graphically to graphically represent the L1 MIS and RNI applied. So you can create some charts and analyze the information to see where you are with the parameters specified by SMF 113. And also you have more information so to understand how the cache MIS is resolved on the cache levels. You have the L2, L3, L4, remote L4, and memory, so you can understand how your data is accessed and how the cache MIS is resolved using the other levels of memory. And when you reduce the RNI or the RNI, of course, you improve your processor performance. But not only the cache levels and RNI and CPI, you have much more counters on the SMF, much more KPIs on your SMF 113. So there you can find the real MIPS by processor. You can calculate your RNI, you can calculate your CPI, and you can understand the CPI because you have the CPI and you have the counter for the overhead cycles used to get one information from cache level, and then you can calculate your CPI used to execute an instruction, but also the cycles used to access the information from another cache levels. And also you can understand the memory hierarchy, also the TLBs, and the cryptograph activity. And here I just put here some examples of the counters you can use, and also, of course, the CPU time used by each CP. All those informations are available for general processors, and those informations are available for zip as well. Apart from zip is not uh, used to when you are working with the consumption, rolling 4 hours average, because it's paid one time, just one time shot, but you have all the informations about the configuration available for zip processors as well. Here is an example how to calculate the CPI overhead. So you have here the entire CPI on this bar, and the part of is the net CPI, that's the green, light green, and the dark green, you have the overhead used to access the data from the other cache levels. So with this, you can calculate and see how many cycles you are spending to access the information from a far cache level. And you can create this kind of chart using all those information inside the SMF 113 records. Okay, so doing a recap, the hardware instrumentation service is not active by default. You have to access, you have to set up the environment to be able to generate the SMF 113. The measure of CPI on a regular basis, it's really nice because you can see how your environment is performing, mainly when you do changes on your environment, like if you change your hardware configuration or your LPAR configuration, or you apply a microcode, and then you can see the before and after to see if you had a change on the behavior of your CPC or not. Okay, and also it can be used for exploitation, because when you apply this feature on the environment, you can see if the CPI reduced or not. And there is no rule for CPI because it's logical that the CPI value should be as low as possible. That means you are performing well on your environment. Okay. Changing the subject right now, we have the workload manager. That's another information that we can see on the SMF records. We can see the activity from WLM. So just for information, the workload manager is a component that you use to define the priority of your services and your process on the ZOS in a Sysplex environment, depending on how your environment is configured. And also the WLM reports the information about the usage, what's going on your environment related to the consumption and the priorities. Everything you define on the workload manager, it's called as a service definition. So you can group them, you can combine and create different policies according your needs, depending on your workload. You can group them in different rules and classes to manage better your process. Of course, you can group them to have a similar, when you have similar requirements on your process, and you can set up different goals and objectives for the service classes depending on your needs. So we have on WLM the SMF 72.3 that's generated by RMF or CMF on an interval basis, each 15 minutes or 30 minutes, depending on the configuration of the environment. And with the SMF 72.3, we have different information about the consumption of the process, split it in the service classes or workloads or importances, or whatever you want to analyze. And we walk through some point of views of analysis on the consumption of the process running on the environment. There is another SMF record generated by WLM, that's the SMF 99, that can be used for that as well. But today we are focused on the SMF 72.3 that brings us much information regarding the consumption that's really interesting. Okay, let me continue. I was talking about SMF 99. That's another SMF that we can use to analyze the WLM. And then I went through some KPIs that we can see on the SMF 72.3. And the point of views, you can see the same information according the entity you choose to see the KPI, the consumption KPIs on WLM. Here is an example of KPIs by workload. So we have the workload here, day by day and hour by hour. You can understand the behavior of the consumption on the environment. And some example of KPIs you have here is the inspection engine used on the environment, the CP time, IMSU, service units, SE on CP. This is a really nice KPI that you can use to understand the eligible workload to run inspection engines that is working on general processors. Also, if you have mobile running on your ZOS environment, you can understand the consumption of your mobile workload, and also the information about service units, PI, and performance index, and other KPIs. If you want to see the information by service class, so you have the same KPIs available for a specific service class, or if you want to see by importance, by WLM importance, you can understand and see the same consumption KPIs. Here is just an example by service class, the consumption on CP time plus inspection engine time. And on the bottom, we have the service class, the PI, the performance index, the IMSU consumption, service units, CP service units, inspection engine service units, inspection engine eligible service units running on general processor mobile. In this case, in my example here, I don't have any service unit, EXCP count, CP time, and SE time. So talking about the performance index, depending on the way you define your service classes, your goals, you can define one period, many periods, depending on your needs. There is a way to measure, to understand if the definition is well or needs to be reviewed. So that's the performance index KPI you can see. And when the performance index is 1, means that the definition is good and the system is delivering the resources according your service class definition. But if it's not 1, so if it's higher than 1, perhaps you need to review your definition because the system cannot attend specifically the definition you have on the service class. But if your PI is under than 1, but it's really under, it's like a 0.1 or 0.2, means that it's really easy to the system to achieve the performance definition, the goal definition. So perhaps it's another way where you can review the definition to try to set up better parameters for the workload. Okay, and this is one representation here just to see the PI factor on a specific service class and the importance that this service class is running and the total amount of service units. Another way to see the consumption KPIs is by the service class and for the specific goals you define. So depending on your WLM class and the different goal types you have on the service class, you have the consumption KPIs for each one of them, for each period. For example, in this first WLM class, service class, you have 3 periods here. And for each one, you have different. So in the first period, importance 1 with the goal 90. The second period, importance 2 with goal 90. And the third period, you have the importance 2, but with 60 on the goal. And then you have your consumption KPIs available here that you can use to understand if the objectives defined are are good or need to be reviewed. Okay. Another way to see the same information, to see the consumption information, is using the report classes. So when you define a service class, you have the report class where you tell to WLM how to report the consumption of the resources on the definition, according to the definition. So you can define the report classes and combine all the similar workloads to have the same report, to be on the same report. And then you can have the consumption KPIs reported by the report class. Okay. And also you can calculate the PI, you can see the consumption KPIs, the use of special engine, and CP time, SC time, etc. Okay, and this is just a chart to show stacked the consumption of the different report classes day by day. Another interesting thing here, if you want to see, if you don't know exactly which jobs are related to the service class, you can correlate the SMF 72.3 with the SMF 30. And then you are able to see the two SMFs, and then you can also understand which jobs are executing on which service classes or report classes or workload names. So this is an example here where I took the service classes, and according to if you select the service class, you have the batch, TSO, and STC jobs that are running on the specific service class. And apart, okay, after you know the jobs running on specific service class, you can also understand the consumption that's provided by SMF 72.3, but also the consumption on the SMF 30. And on SMF 30, you have also the MS use consumption execute the service units consumed by the job. So you can make a relationship between the two SMF records to understand the consumption. And this is the part I mentioned when I start to talk about WLM KPIs, the zip eligible process running on CP. So for the workloads that can run on zip, but there is no room to execute, they are automatically sent to the general processors to be executed. And using the SMF72, you are able to understand the amount of those eligible workloads that are running on the CP. And this is really important because here we are talking about billing, because everything that runs on CP, it's related to the billing, and what is running on zip, actually you don't have billing on that because the metrics for payment, it's completely different. You don't have to pay anything on the workload you are running on the zip. And then if you have much workload running on the general processors that were eligible to run in zip, you may have impact on your billing peak, because your rolling 4 hours average probably will increase, and then you pay more for IBM. And using this SMF record, you are able to understand the amount, and perhaps you can do some changes on the definition in order to use better your zip processors. And this is an example here just to show a DDF that's a well-known process that comes from a distributed system running on DB2. And this process uses the zip processor a lot. And here I have an example of 42% of the total workload is running on general processors because the zip processors are busy executing other stuff. Okay, so and then that was a nice picture to represent this workload running on general processors. And I think that's it for today. Here I have the reference I used to prepare this presentation. So the two first books are related to HIS, and the third one related to the workload manager. And there I could find all the information I showed during this presentation here. Okay, if you want to know more about ZLE company, so please go to the website www.zle.io, and there you can understand and see our solutions, and you see how we can deal with the huge amount of SMF records using analytics. Thank you very much for your time, and please, if you have any question, it's time to ask.
Okay, so thank you, Roberto, for your time in presenting this session. If anyone has any questions, you may put them in the chat, or I am going to give you the ability to unmute yourself. I will leave the session open now for question and answer, general conversation. Please remember to go and provide feedback for the session, both to help Roberto and to help us for GSE planning for future events. This year's charity for GSE is the National Health Service, and as you didn't have to pay a fee to attend the session, maybe you'd just like to make a small donation to the charity. Think of it as buying a strip of raffle tickets. You didn't expect to win anyway. Okay, so Any questions? You are able to unmute yourself if you just want to have just a chat amongst yourselves. Okay, over to you. Roberta, there is a question in the chat from Brian Sanger. Roberta, can you talk to any specific analysis that was done that helped your site? I guess that would be to a customer site.
Okay, mainly what I have experienced with our customers, actually based on the PI, we did an evaluation on how the service classes were performing, and we could see some process running with a high PI, and we passed to the customer to see if he could change the behavior, the goals defined on the service classes, and then with that we could improve mainly the DDF execution on the environment, because it was running very the speed was not so good. It was running very low on the activity, and then we made some changes on the PI, and the workload ran better with those changes. Of course, what we find in many shops is the definition of WLM is not well. How can I say? We have some standards that we can use on the WLM definition, and not all shops follow the standards. And then sometimes what we face is that we need to reset the WLM definitions to better organize the DB2 workloads, the KICS workloads, the network workloads, and the batch process. And what we have seen on some customers as well is the batch activity running on importance 3, sometimes importance 2, because they want to fit all the process on the batch window, and sometimes it can cause troubles to the environment, because the batch workload is invading, for example, the online window, because they need to finish some services. And that's what we have seen on the market and on our customers with the WLM definition.
I hope that answered your question, Brian. As I say, you are all able to unmute yourselves if you wish to have any other questions. Or just chat. Okay, I will leave this session open for another 12 minutes to 10 o'clock, the finish time. You may use it as you like.
Okay, I think we don't have any other questions, correct, Anna?
Correct. Nothing in the chat.
Okay. So Thank you very much, everybody, to join us during this presentation, and have a nice day to everybody. Thank you, Anna, to support me on this session, and
No problem.
hope to see you soon. Okay, thank you very
Okay.
much.
Okay, I will close the session now then.
Okay, thank you. Bye-bye.
Bye.